Hey guys, it's Mr. Lancaster. It's Friday, May 1st, and I hope you're all having a good Friday. Friday. I hope you have a good weekend too. I know you're probably excited. We have about a month and a week or two of school left. And yeah, so we've been talking about volcanoes, mountains, and now we're going to be talking about landslides. So I want to show you this video on Mystery Science, and it is so cool. I think it's going to blow your mind. Let me share my screen with you. So if you go into, let me share my sound. Okay, so if you go in here to my Google Classroom as usual, let me show this just in case. So you go into Lancaster 4th, go to classwork, then you go to the science, under science linked activities, and you go all the way down to how could you survive a landslide? So how could you survive a landslide? Let's see what Doug has to say. My man Doug, I like Doug.
Tornadoes, wildfires, floods, earthquakes. These are what we call natural hazards. And these are ones you know something about. You could probably think of others you know about. Hurricanes, avalanches, tsunamis. Hi, this is Doug. All of the natural hazards I've mentioned get lots of attention on the news. Today I want to tell you about a hazard that doesn't get much attention, but it should, because it's much more dangerous than many people realize. This natural hazard has something to do with rocks falling from the mountainside. I'm talking about landslides. In one of my favorite books, there's a story about a family that experienced a landslide. They're named the Genophile family, and they lived right around here on a mountainside near the city of Los Angeles in California, USA. One night, they woke up to the sound of thunder. A storm was raging outside. Outside of their house, something like this is what was going on.
Holy
Now,
moly.
that's not a river of water going by. It's more like a river of land, actually. There's mud, there's pebbles. You see all that? There's rocks in there. Look at all those rocks. Do you see that? Look at how big some of those rocks are. That's a boulder right there that's going by.
Holy moly. If you got under that thing, you wouldn't be crushed and you'd be not here anymore.
But for the Genophile family, this wasn't just happening outside their house.
Humongous.
Imagine all of this flowing into your house. That's what happened to the Genophile family that night. Rocks smashed through the bedroom wall of their two teenage children, Jackie and Bob. And boulders like this started filling up the room. As more and more boulders tumbled in, their beds were rising. By the time the landslide had finished crashing through their bedroom wall, their beds had been lifted up so high that Jackie and Bob could press their palms against the ceilings. Amazingly, everyone survived. When all was said and done, the Genophile family walked out of their house and looked around the yard. Boulders and cars were everywhere. There were even a few cars in their swimming pool. Landslides don't just happen in mountains next to Los Angeles. They could happen near any mountains. But what causes a landslide? What causes loose bits of rock to all come rushing down a mountainside? Why do you think all the rocks came down at once?
So pause the video and stop to think about this real quick. Why do you think all the rocks came down at once? What happened? What caused for this to happen? A clue is that day when they had that landslide, the family they said they woke up to thunder. So when it's thundering, most of the time, or all the time, but most of the time, it's doing what? It's going to be raining. So if it's raining, you think maybe that is a reason why all the rocks came down at once? Could be. Let's keep going.
Up on the tops of mountains, there are lots of loose rocks and boulders. You learned how they break loose. It's things like freezing water and plant roots that can break the solid mountain rock apart into smaller pieces. Now, normally after that happens, those loose rocks stay where they are. But when it rains, that makes the mountainsides slippery, and so when that happens, it's possible for lots of loose rocks to slide down the mountain all at once. So rain is one of the things that causes landslides. Like, watch this video taken in Taiwan. You can see it's raining. There's cars driving on a mountain road. You see the mountain on the side. Now keep your eyes on the white car in front. I'm not going to say anything more. Just watch that.
Oh my, oh,
Can you imagine if that was you in that car?
oh my goodness.
Incredibly, no one was hurt.
Woo!
But still, what are the chances of something like this happening?
Look at the size of that thing. It's bigger than a truck. If that would have rolled over,
Well, let's look at this slope. If a hill or a mountain is only slanted this much, that might not be enough to get a loose rock rolling. But if it's slanted this much, any loose rocks are much more likely to start rolling downhill now, aren't they? Scientists have measured the slant or the slope of mountains like this, and angles of about 35 degrees or more are usually what worries them the most. Less than an angle of 35 degrees, and any rocks that come loose might just sit there forever. But at around 35 degrees, that's an angle that, when wet, now any loose rocks tend to come tumbling down. Surprisingly, the worst kind of landslides occur with rocks that have already tumbled down the mountain. Like this pile of loose rocks right here. You might think, well, if they've already tumbled, then everything's good, right? Where else could they go? But consider an example from real life. Like, you see this other little slope right here? That's a bunch of loose rocks. They've all tumbled down the mountain, and now it's its own steep hill. There's even a little forest of trees growing on that one. See, here's a close-up. Well, in Japan, there was a steep hill like this, where someone had built a road. And here's the actual view when standing on the road. This video was taken in nighttime. It had recently stopped raining, but it had rained a lot in the previous days. And you see what's happening? Look at that. There goes the power line, and there goes an entire forest of trees right past the view there. Wow. Just to show you, if you were to look at something like this the next day, this is what a hill looks like after a landslide like that.
so the guy built a road on the side of a hill. Probably not the best idea. But even if it wasn't a bad idea, I mean, sometimes roads have to go through some hills like that. So how would you have known it was safe or not? Well, this is exactly what we were talking about in our last video. We're trying to predict to see, the geologists are trying to predict to see how landforms are going to behave in order for us to know what's safe and what's not, so we can predict things. And this helps us a ton, and just being able to stay safe and just know the world around us. And this is what is so awesome, because you guys can become geologists and other types of scientists and have jobs and engineers like this, and this will be your job one day if you want it to be. You know, you won't be young forever, so trust me, I know I used to be young like you, but you're going to be old like me one day, and you'll want to do something. So go ahead and start thinking about, is this something that you'd want to do? There's many jobs out there, but maybe you would be good at something like this, and maybe you would enjoy it.
At the next day, you could see the whole side just slid off. Do you notice the trees down there at the bottom? They used to cover the whole side of this hill. A landslide similar to this one happened in Washington State in the US in 2014, killing 43 people. So landslides are a big deal. Now that you know something about landslides, you might have some idea of how to be safe. Say you were trying to decide when and where to go camping in a hilly area. What kinds of things might affect whether a landslide would occur?
So what would you look for to decide whether it's a safe place to camp or not? Well, one thing is, like he said before, is that angle, 35 degrees. If it's more than 35 degrees, then you know probably if there's a lot of rain, it's not going to be very safe. Another thing is that mudslides happen, which are caused by usually a lot of loose dirt. So if it's a relatively new mountain, there can be mudslides. There was a mudslide that happened in the high country, and these happen sometimes. One was in Avery County, and this happened right here, and it just completely took out an entire road and went all down the mountain and everything. This isn't like a rare thing. This happens every now and then, but this was a very big one that happened. So that happened in 2013. They had to completely close that road down. Avery County is just the county over from us, about 30-45 minutes. So some things that you can do is look at the angles, look to see what's around you, look to see, would this be something that would be easily moved? Sometimes it can be hard to tell, but yeah. So we're going to skip this activity and we're going to go here. I want to show you this cool video. These scientists,
experimental component,
they make landslides to study them. Isn't that cool?
of our work is conducted largely at a facility we call the USGS debris flow flume. This is basically a huge concrete chute built on a steep hillside about 50 miles east of Eugene, Oregon. And what we do with this facility is mix up batches of debris that are very similar to natural debris in debris flows, and then let them flow down the chute from a distance of about 100 meters. And this allows us to make lots of measurements under controlled conditions, and additionally allows us to repeat the experiment over and over to make sure that we're getting replicable results. And without that kind of experimental testing, it would really be difficult to know whether our models are performing as well as we would like them to. Some of our models have been used extensively throughout the world for making long-range hazard forecasts, and also sometimes implemented in sort of an emergency situation as well. And that's really gratifying to see that the science has that kind of practical application. This work really does lead to saving of lives and additionally to protection of property to some degree.
What in the world happened?
My name is Richard Iverson. I'm a research hydrologist at the U.S. Geological Survey Cascades Volcano Observatory here in Vancouver, Washington. Steep piles of rubble, and there's nearly an infinite supply of to know whether our models are performing as well as we would at the U.S. Geological Survey Cascades Volcano Observatory here in Vancouver, Washington. My work focuses particularly on the dynamics of debris flows, debris avalanches, and other kinds of mass movements that occur at volcanoes and also can occur in other settings as well. Debris flows are basically masses of rock and mud and water that travel rapidly down slopes and downstream under the action of gravity. Volcanoes are a particularly ripe setting for large debris flows and debris flow disasters, in part because there are these huge steep piles of rubble, and there's nearly an infinite supply of loose debris sitting there that can possibly get involved in one of these flows. It's important to realize that the hazard around volcanoes like those we have in the Northwest goes well beyond the immediate environs of the volcano. It extends well downstream in lowlands areas, perhaps as much as 100 kilometers away from the volcano, as a result of these long-travel debris flows. The goal of the research group that I lead is quantitative forecasting of hazards from debris avalanches and debris flows. That work involves several components. There's a field component that entails simply observing and measuring what happens when these events occur naturally in the field. There's a laboratory experimentation component that involves making artificial debris flows at our USGS debris flow flume. And then there's a mathematical modeling component, part of which involves actually deriving appropriate equations to describe the behavior. And then there's the task of actually solving those equations and portraying predictions on a computer. The experimental component of our work is conducted largely at a facility we call the USGS debris flow flume. This is basically a huge concrete chute built on a steep hillside about 50 miles east of Eugene, Oregon. And what we do with this facility is mix up batches of debris that are very similar to natural debris in debris flows, and then let them flow down the chute from a distance of about 100 meters. And this allows us to make lots of measurements under controlled conditions.
All right, so there was that. That is so cool. And we're not going to read this because the video's gotten long enough, but this is probably, this is slow motion landslide threatens homes in New York, but this is probably the biggest landslide in the state's history. It moved 81 acres of land. And just like this lady's house that she paid a lot of money for, she paid $600,000 for it. And then it completely, it leaned over so much it's no longer safe to live in, and she can't sell it, she can't do anything with it, she's just at a loss, which really stinks. But that and about 11 other houses were at risk, so that was really rough. Things like that happen sometimes, so we gotta try to be ready for those things. But yeah, well, anyway, guys, hate to end off on a bad note, but that's why we do these things, is so we can try and make people's lives better, and hopefully you want to do something like this one day, or something else that'll help people out. And that's why we do all this math and science, to get us ready for it. Well, it was good seeing you guys, and me and Goose say bye. Bye.